The general sine function can be written as follows. Write one sine equation for the function shown in the diagram. Let's find the amplitude. The amplitude is 1/2 the difference between the maximum and the minimum value. The amplitude is 2 units. We now can draw a midline. A midline of a sine function is the horizontal center line about which the function oscillates above and below. So the midline is parallel to the x-axis and is located halfway between the graph's maximum and minimum values. The distance between the midline and the x-axis is the vertical translation. Therefore, c equals to 1. The period is the horizontal distance it takes for the function to complete one cycle. The easiest way to find this is by looking at the horizontal distance from a maximum point to a maximum point, or from a minimum point to a minimum point. The period is 4 times pi, and b equals to 1/2. For a sine function, the horizontal translation is found by looking at the x-coordinate of a point on the horizontal axis of the wave with a positive gradient. Look at the graph. This could correspond to the origin on the standard sine graph. Therefore, the horizontal translation is minus 5 pi over 4. We now substitute the values to get the sine equation. Pay attention. On the same set of axes, sketch the graph of function. We start by comparing the function given with the general sine function. We now see that the amplitude is 1 unit, the vertical translation is 1, and the value of b is 1, so the period is 2 pi radians. K equals 2 pi over 3, so this is the horizontal translation. Draw the Cartesian plane. The distance between the midline and the x-axis is the vertical translation. C equals 1, so we draw the midline. The amplitude is 1, so the maximum value is 2 and the minimum value is 0. So we get the range of the function. We determine the values of theta for the start and end of one cycle from the given function. The period is 2 pi and the horizontal translation is 2 pi over 3. We sum 2 pi over 3 with 2 pi. So we can think of starting the graph in 2 pi over 3 and finish in 8 pi over 3. As an aid in sketching the graph, we divide the period into 4 equal parts, each of length pi over 2. So we start from 2 pi over 3 to 8 pi over 3. Complete the table. Plot the 5 key points and connect them to obtain one cycle of the graph. Extend the graph in each direction to make it complete.